Okay, so let's look at E1. So E1 has to do with conservation of energy. So it says a bird is flying with a speed of 18 meters per second. Over water when it accidentally drops a 2-kilogram fish. If the altitude of the bird is 5.40 meters, what is the speed of the fish when it hits the water? So we're given the initial velocity, we're given the mass, we're given how high it is above the ground, and then we want to find the final velocity. You know, again, you can draw a picture, but here, remember, you have a fish, and it's going to fall. So this is the initial part, and then this is going to be the final. So remember, when you're first practicing to do this, think about conservation of energy in layman's terms. And layman's terms means that the total energy before is equal to the total energy after. So remember, the total energy, the total mechanical energy, is the sum of the potential and kinetic. So PEI plus KEI is equal to PEF plus KEF. Now this problem's a little bit different because the initial velocity of the bird is not 0. So we're not dropping it. So now I'm going to write down, well, the potential energy is mgh. So this is going to be mghi plus 1/2 mvi squared is equal to mghf plus 1/2 mvf squared. So again, first I'm going to write in layman's terms, then I'm going to write, what's the sum of the mechanical energy, the potential and the kinetic. Then I'm going to write the equation for each. This isn't a big, long equation I have to memorize. All I need to know is potential energy is mgh, kinetic energy is 1/2 mv squared. Okay. Now before I go on, I'm going to say, is anything 0? So here, it's moving at a velocity of 18, and it's the height above the ground. Right before it hits the ground, the potential energy is 0, so this is one of the terms that I can get rid of. So anything that's going to be 0, I just want to simplify. And then I'm going to say to myself, what am I solving for? I'm solving for VF. Now what I would do, this is now an exercise in algebra. I want to make this easier. So you see all those 1/2s in there? What would be a good way to get rid of those 1/2s? Multiply everything by 2. So go ahead and do that. Does anyone see something else that I could do to simplify that before I multiply anything by 2? Is there something that's in every equation? M. So even though they gave me the mass, do I need it? So let's just get rid of this. There's an M there, there's an M there, and there's an M there. Then I'm going to multiply everything by 2, so I'm going to end up with 2ghi plus vi squared is equal to vf squared. Now it looks a lot easier for me to solve. And remember, we don't want to just start plugging numbers in, because with all these m's and 1/2s, you see you would have a mess. So I want to simplify it as much as possible, and I want to rearrange the equation to solve for the unknown in terms of the known. Well, my unknown is VF. A lot of times people forget, because something's squared, to take the square root at the end. So I would go ahead and do that and say the square root of 2ghi plus vi squared is equal to VF. So now I'm going to substitute in my values. So it's going to be 2 times 9.8 meters per second squared times 5.40 meters plus 18 meters per second squared. So this comes out to be 20.7 meters per second. So again, for conservation of energy, we do it step by step. I would start off, again, you're not memorizing some long equation. Just say the total energy before is equal to the total energy after. The total mechanical energy is the sum of the potential and kinetic. I know potential energy is mgh, and I know kinetic energy is 1/2 mv squared. And if you do it step by step like that, you won't have any problem finishing this homework.